Welcome, this is results-oriented preparation. I'm Kenneth, and in today's video we are looking at stoichiometry and calculating the empirical formula of a compound. Now, before we go into the video, please remember to share, subscribe, hit the notification button to get our new and upcoming material. Thank you. We go straight into our question. Remember, we are dealing with empirical formula. The question reads, what is the empirical formula of a compound containing 40% carbon, 6.71% hydrogen, 53.28% oxygen? All right. So we know that our compound has got these three elements, that is carbon, hydrogen, as well as oxygen, in those percentage composition. Now, for us to find the empirical formula, our starting point will be first to do something like fill this table. Now, the reason why we are filling this table, we want to find out exactly in that the proportion or the ratio of carbon to hydrogen and to oxygen in our compound. So we will deal with, first and foremost, the percentage composition divided by the molar mass. We know that the percentage composition here is 40, right? 40 divided by the molar mass for carbon is 12, all right? 40 divided by 12 will give you 3.33, all right? So we know that that percentage composition will be 3.33 divided by the molar mass, 40 divided by 12. And then next we go to hydrogen. The percentage composition of hydrogen in our case is 6.71 divided by the molar mass of hydrogen, which is 1. And then this one will give us the same number, 6.71. And then next, oxygen. The percentage composition of oxygen in our compound is 53.28 divided by the molar mass of oxygen, which is 16. 53.28 divided by 16 will give you 3.33. All right. Now that we have found that those figures, we need to divide all the amounts that we have there by the smallest figure. All right. You will see that we found 3.33, 6.71, as well as 3.33. So the least figure there, the lowest, is 3.33. Now we take the first one, 3.33, this one, 3.33 divided by 3.33 will give us 1. All right. And then 6.71 divided by 3.33, this will give us 2. All right, that will give us 2. Okay, and then the next one, 3.33, again divided by 3.33, is going to give us 1. Now, from this we know that the empirical formula, I'll write it in short, empirical formula for our compound is going to be C has got 1, right? And then hydrogen we have 2, and then for oxygen is 1. So that is our empirical formula for the compound. Now remember, first and foremost, you need to check the percentage contribution or this percentage appearance of each of those elements, what they are contributing to that particular compound, divide by the molar mass to get that ratio there. Once you've found it, divide by the least amount to find the ratio of one element to the next. So we know that in our compound we are going to have 1 carbon, 2 hydrogens, and 1 oxygen in that particular ratio. All right, now the question goes further and says, determine the formula for the compound in question 1 if the molar mass is 180 grams per mole. All right, we're given a molar mass of 180 grams per mole. All right, that is the molar mass that we've been given. All right, so we want to find out exactly the molecular formula of the compound, given that the molar mass is that. So what we are going to do then is, first and foremost, find out the mass, the total mass for the empirical formula. All right, so the mass for that is, we're going to find the mass for, let me write it that way, mass for CH2O. All right, okay, so start with carbon. We know that carbon, that's 12, all right, plus 2 times 1 for hydrogen plus oxygen, which is 16. All right, 12 plus 2 plus 16 will give us a mass of 30 there. All right, that is our mass. Now, once we've got our mass for 30, then we want to find the ratio of this mass to that. All right, the ratio of the molar mass of 180 to the mass of the empirical formula. Okay, so the ratio there, the ratio is going to be 180 divided by 30. All right, remember, what we're interested in finding here is to find the amount of moles that will be there in that, okay, in that particular 180 grams per mole. Now, as you can see, 180 divided by 30 will give you 6. All right. Now that we found 6, we multiply the 6 with the empirical formula. So we're going to take 6 times CH2O1. All right, CH20. Okay. Once you've done that, we can clearly see that we've got 6 carbons there. 6 times 2, we've got 12 hydrogens. 6 times oxygen, we've got 6 oxygens. So, as you can see, that will give us the molecular formula if the molar mass of 180 grams per mole is related to the empirical formula. We already found the empirical formula only gives us the proportion of carbon to hydrogen to oxygen in our compound, right? The empirical formula gives us the proportion of carbon to hydrogen to oxygen in our compound. Now we know that the empirical formula there in our compound will have 1 carbon is to 2 hydrogen is to 1 oxygen. Once we have found that, then given that the molar mass of 180 grams per mole, all right, the molar mass for this compound, then we are able to work using this one to find the actual molecular formula of our compound. To do so, first we found the mass that is related to the empirical formula in its general format there, which will give us 30 units there, all right? And then we divide by finding the ratio of the molar mass to the mass of the empirical formula, which is 180 divided by 30, which gives us 6. Now that we've got 6 there, we multiply the empirical formula by 6, giving us C6H12O6. So that is the molecular mass for that particular compound. I hope you enjoyed this demonstration. Please don't forget to like, to share, subscribe, and also hit the notification button to get new and upcoming videos. I hope you enjoyed it. See you in the next video.